the random variable x, right, has the binomial distribution NP, where P is between 0 and 1. Given that the variance of x is 4 over 5 of EX, find the value of N such that the probability of x greater than or equals to 1 is greater than 0.92. Okay, so here we have x, right, be the binomial distribution of NP. Okay, N is the number of trials and P is the probability of success in each trial. Given that variance of x is equals to 4 over 5 EX, right? So we have that the variance of x. We know that this is a binomial distribution, so our variance of x can otherwise also be written as NP 1 minus P. Now, expectation of x can also be written as NP. Alright, we also know from the question that variance of x is equals to 4 over 5 E of x. Alright, this means that our NP bracket 1 minus P is equals to 4 over 5 NP, correct? And you see, if I were to just remove NP on both sides, I can factorize. This just means that very quickly you can solve this. 1 minus P equals to 4 over 5 and P equals to 1 over 5, right? And if P equals to 1 over 5, you can also say that Q, which is 1 minus P, just equal to 1 over 5 is 4 over 5. Alright? So next thing we know, we want to find the least value of N such that the probability of x we want x greater than 1 to be more than 0.92. Okay, so if we think about this, right, greater than equals to 1, greater than equal, we want to convert this to a less than probability. This is the same as writing with 1 minus the probability of x less than 1, correct? So it's probably equals to 0, am I right? Because what are the values? Right, the value, okay, greater than equals to 1, right? So it's equals to 0, right, to be greater than 0.92. Okay, so the probability of x equals to 0, right? If I just bring 1, I mean just to arrange my terms, this will just be less than 0.08. Alright, so x less than 1, basically x has to be just 0. Okay, and with that, observing this, right, what is this? If we use the binomial formula, this is just like n choose 0, right, and p to the power of how much? P to the power of 0, and then 1 minus p to the power of n. Am I right? Okay, so this is just going to mean that basically it's just 1 minus p to the power of n to be less than 0.08. Okay, 1 minus p, as we know, is just 4 over 5. So it's 4 over 5 to the power of 0.08. And solving this, I mean, if you log both sides or use a GC, very quickly you can see that basically n has to be greater than 11.3. So you can use GC or you can log both sides. So that means, right, the least value for n at least has to be 12. Alright, so this is how we actually go about doing this. Right, we go about doing this. Okay, because cannot be non-negative. Alright, we cannot have x to be equal to -1. So x, the smallest you x, you want the complement of x greater than or equals to 1. We're just taking 1 minus the power of x equals to 0. And from 0, you can see that I go on to solve this, okay, using the formula of binomial distribution. Okay.